Good afternoon, good evening, sorry. What we have done, we have curated some of the problem statements which we expect, like you can try to solve or you can analyze the data. So we are uploading, there is some hiccup in the data. So, but we will trying to upload the data sets like images. Like these are the problem statement. Like first one is the rainfall from IMD grid data. So what we'll do, we will upload the IMD gridded data in a CSV format, day, daily data for current season. So what we'll expect you to like in my slide, I shown that. Let me just open my slide. So what we expect, you can generate these kind of products using the grid data, means dry spell based on like 7 days dry spell, how many 7 days dry spells have occurred, how many 21 days, 14 days. So with CSV file having the latitude, longitude, we will upload. We are trying to upload. So by the evening, I think we'll upload. So one by one, I'll just explain the task, and then you can using that link, you can download the data and you can try to do the exercise. So first one is using IMD. Then second one, what we expect is we'll share some of the Sentinel-2 images along with some of the ground truth points. So what you can do, you can this task you can either you can do using your software which you are already having, or you can analyze using the Earth Engine. I'll try to show some of the steps what you can do, how to access the imagery, how to access the algorithm and GT points and all. Then third one is the flood mapping. So in this, we will share 2, 3 images, pre-event, post-event images. So using those images, you can create some logic to extract the inundated area based on the SAR backscatter values, change of the rate of the change of the SAR backscatter values. Next one is basically crop health, like generating various indicators, like from Sentinel, NDVI, how to generate the NDVI, LSWI images. So we'll share the data sets folder wise, task wise. Then also using the Sentinel-1 temporal data set for the whole season. There will be part of the Punjab. So you can do the crop mapping of the rice based on the backscatter. Then the sixth task will share some of the parcel segmented boundaries of particular area, small village or maybe a block, and Sentinel stack, NDVI stack for whole season. So you can do the clustering kind of thing, and you can generate the crop map, single season, double season, means double cropping or triple cropping. These kind of analysis you can see, or fallow. So both the parcel boundaries along with the images NDVI stack will share. Then identification of the stubble burnt area. This either you can will share some of the image of around October or November where this stubble burning happens in Punjab. So this you can do the analysis either in the Earth Engine. Also you can try, because there no need to use this data. You can directly generate these indices in the Earth Engine. Then tracking of sowings and harvest pattern. We will upload the crop mask, wheat crop mask of particular districts along with the 10-day image Sentinel composite of whole season from October to March, maybe April and May. So you can generate some kind of sowing map based on the NDVI, how NDVI value is progressing using some logic. So if a NDVI value threshold is greater than certain value like 0.3 or zero 0.4, and the trend is increasing, so you can detect the particular sowing fortnight of sowing decade. And based on that, you can generate a late soon or early soon kind of man. And similarly for the harvest, at the because you have a wheat map and you have NDVI values for all the fortnights or all the every 10 days. So you can see, okay, when the value got below 0.35 and continuously below 2, 3 decades, so you can establish the harvesting time of the crop. So these kind of logics you can, so all the data sets we will upload. Then all India grid rainfall data for temporal. So we'll upload 30, 40 years, I think, gridded data of IMD. So you can do some kind of a temporal analysis, like for either generate some kind of SPI or some kind of long-term analysis. What is the trend of the rainfall pattern? Then this drone imagery will try whether it will will be able to get or will be able to upload because it will be very size will be very high, very huge. So we'll try this one. We'll try to upload drone imagery. आपके drone imagery है? We have drone imagery or drone 10th one. Drone imagery will be able to upload. No, I so it depends on size because the size is very big. So we'll see if we'll be able to upload. So we'll share this also. Then we'll share the past 6 year paddy crop map of Haryana state. So you can do some kind of analysis. Okay, how much common area is there in the 5 6 years, in 2 years, 3 years. So basically, you can see in a single plot or single area, every 6 years paddy is happening. So how much percent area is that? So these kind of analysis can be done. How frequently uh, how the basically the area of paddy is changing. So you can over the 5 6 years you can analyze those kind of you can create the maps like one time paddy, two time paddy, three time paddy. These kind of analysis can be done. And similarly for soil moisture SMAP from 2015 to current season, we have every 3 hourly we uploaded. So some kind of anomaly analysis can be done like from the average past 6 7 years, you can create an average soil moisture. Like I'll show you some kind of imagery here. You can even in season change also can be done. How much soil moisture is changing in season. Like this kind of anomalies can be generated. Okay, what are the areas where the deviation of soil moisture and compared to, like you can see this is the current season. So you can see the Karnataka, Maharashtra, and some part of Saurashtra, means Gujarat. So these kind of anomaly from the past, so 8 years data we will upload. Similarly, in the flood one, we would expect you can generate using the before and after images. These kind of extract the pixels inundated due to that rainfall during that period. And similarly for the sowing harvesting using these kind of profiles, you can generate these kind of profiles at pixel level, or you can in some region you can generate the profiles. So you can see at what time you can establish crop sowing has taken place and harvesting. So these kind of pattern maps using those images. So of course we'll share the data for only one or two districts. So these kind of basically maps you can try to generate based on the NDVI trend, how NDVI is increasing, early sown, late sown, or normal sown. So these are the activities you can try to do on your own. If anybody knows Earth Engine or anybody want to ask anything how to do, so I can show you some of the examples how it can be achieved. Like for the flood, it's I can just if you're able to see it properly, I'll zoom it a little bit. You can if you are a Google user, you have a Gmail account, so you can create a Google Earth Engine account and you can start using this. So for calling any imagery, like for this is for Sentinel one, you can simply call a collection like e.image collection in Earth Engine. So these are the basically image collection name. So whatever data set you want to access, so there is a in a Google catalog, you can search that data, you will get this name of each data set. So like this is for Sentinel 1 GRD. So you can call the images. After that, you can filter it whether you want to use a VH or VV polarization data and ascending pass or descending pass. So these are the basically how you can filter the data, and then you can easily filter between the pre-event image and post-event. So this is this line of code you can use for only filtering your data sets based on the polarization and descending and ascending pass. Thereafter, using this collection, you can filter based on the date. Between these date, I want to make a mosaic of a particular area. So basically, like 22 June and 24 June, because the heavy rainfall occurred in Delhi during that period. And then you can filter based on your bound. So you can upload your own shapefile here, assets. Otherwise, there is a provision you can simply draw either geometry tools are there. You can draw all area of interest here, then you can use that directly. So you'll have before and after images period. So you can load those images as you can clearly see here. This is the part Jamuna river bed is here. So you have to basically first find out the area of where flood have occurred this year due to the heavy rainfall. So before and after images you have to figure it out, and then you have to basically you have to put some logic how to extract this area where in the pre-event image there was no water logging is there, but after the event there is water logging there. So those values you can check the backscatter values here. You can use some ratio, okay, because water value is generally minus 20, minus 22 dB. So you can basically see, okay, if the after image is less than minus 20 and it is greater than, it is lower than by 5 dB from the previous date. So that logic you can use and you can filter out those pixels. Like here I use the simple, after image it is minus below minus 20 and before image it is greater than 20. So you can change it to 15 or 16 based on the pixel values and you can extract the inundated areas like this. You can see the black pixels. So we'll share the image in the TIFF format also, but you can try to do in Earth Engine also. And even after that, there is the area function direct function is there. We'll share these link. I think we can generate the link of this code also, and we'll share that. Uh, we'll put it in the basically in the Word document. And yes, no, that you have to basically. That's why you have to set for setting the threshold. You have to check the pixel values, how it is changing. But generally, if you see the water is generally below minus 21, minus 22. But yeah, if you go for the RI set data, this is Sentinel I'm talking about. RI set data, VH polarization or V polarization, it may be different because we have observed in some polarization there may be a difference of inter-sensor difference will be there definitely. So you have to that you have to check first. But generally, it is for Sentinel, it is generally water minus 21 or minus 22 like this below that. But these sometimes, if a fallow land is there before the season and it is perfectly plain, it will act as a water only because it is side looking. So it will go away. So you will see a black image. But what that's why we are taking pre-event and post event. So we are assuming that this heavy rainfall occurred and this inundation or occurred due to that. So that's why you have to figure out the time, good time of the images also. And then you can even calculate the area of that, how much area has inundated. So you can compute the area here, and in the console you can print it out. Okay, how this much hectare area is there. So these either you can even do those images we will share in the TIFF file. So you can in the QGIS raster calculator is there. You can use the logic there, and if you have some your proprietary software does and everything, the model maker you can use the models and you can generate these kind of things. Similarly, for let me just show you some logic for what we use for harvesting. So like this is for the Sentinel optical 2, oh, sorry, Sentinel 2 optical data. So here we are accessing the collections Copernicus Sentinel 2 SR harmonized data, surface reflectance data. So we are accessing this data 25 September. So this is how you access for optical data. Simply you have to collection. Then filter bound is my Punjab state. I have given filter. I have uploaded the shapefile. Then you can create the NDVI. Like here you can see how we create the NDVI. Simple. If you write normalized difference, B8 is the NIR band, B4 is the red band. So you can create the NDVI simply. And LSWI also simply you can create if you know the using SWIR and NIR. So harvesting basically what we are taking if the particular pixel value is less than 0.3. So we are reclassifying the NDVI imagery into following classes. Like you see, less than 0.2 is definitely a fallow. We have a crop mask. Already crop mask of paddy is uploaded here. We have uploaded. This is the crop. This is how you upload and you can call if you upload the image in the asset here, your raster file you can upload, then you can simply call image and this is the path where it has uploaded. Kharif price mask. So we are only checking the Kharif uh, mask only, Kharif paddy pixels. And we are classifying it okay. We are saying below zero point 0.2 is definitely it is harvested because NDVI value has gone below zero point 0.2. Of course, you have to do the cloud masking also first. Otherwise, cloud values can also go below zero point 0.2. Then 0.2 to zero point 0.3, you can say still it is harvested. And 0.2, 0.3 to zero point 0.4, we can say, okay, somewhere it is near to harvest or crop has matured. So these classes you can generate based on your NDVI values and based on the experience also people know okay, less than 0.35 something we say around 0.3 the crop is mostly harvested. But of course, it's a surface reflectance, so NDVI value is much higher. But if you use TOA, so it's a top of atmosphere, definitely less than 0.35 also you have to take. So it will divide into classes, and for each of these classes, further if you calculate the area, so you can get the area also in each of the class. So then you can say, okay, this much of the hectare of the area has been harvested. So this is simply, yeah, this 1, 2, 3, 4, 5, 6 classes. So it is computing the class in each of the area in each of the class. Then you can say, okay, this much area harvested, and you can even generate the a map with these legend. Okay, near to maturity, crop matured, harvesting stage, or crop harvested. These kind of map you can create, and you can see the areas where crop has harvested. And every 5 day you can track this. Every 5 day pass is there. You can track how much area is harvested, and even you can generate a harvesting pattern map also. Okay, where early sown is there, where late sown is there, like this. Like this is for the 6 states. So brown color is showing the late. So this, sorry, this is the sowing map. Let me show you the harvesting one. This is the harvesting latest to that. So only this part of, as of Punjab, this part of is coming as in Amritsar crop harvesting. It is showing the harvesting signature, and you can clearly see in the images. So these are the black one and this one are harvested. But red one is showing the standing crop. So these kind of pattern maps also, if you over the October end or November end, you keep on adding these maps and you can generate the statistics. So you'll get the very good harvest pattern map also. And similarly, these logics can be applied for the sowing also. You can, for particular pass, you can see, okay, if NDVI value is greater than zero point 0.4 or zero point 0.3, and in the later on images also, first is detecting, then you are validating it. Okay, after next 2 decades, 10-day image, NDVI is increasing trend. So you can definitely say that's a crop is increasing and crop is sown in that particular fortnight, or because we have to take a 20 days back kind of sowing. Because if NDVI right now is 0.4, you can say around month back crop has been sown. So that offset also somewhere we have to apply. So these are the logics you can apply, and we'll share the link of these also. And in the same also we have applied the one index is there. Maybe I think mid infrared index is there for burning burnt area kind of analysis you can do using the soil bands. So if you are accessing the Sentinel imagery, you can, this is the formula, soil 2 band into 10 subtract by 9.8. There's a formula. Maybe if you Google it, so you'll get the maybe for burnt area. And there is a threshold. So around 1.75 or 1.8 threshold is there for that. So if it is greater than 1.75, it is a burnt area kind of thing. So if you threshold this, so in a single code, you will get FCC image, NDVI, LSWI, then you will harvesting class, and then burnt area. So these kind of analysis you can do here without any downloading a single data set. But in that folder, we will upload the images, actual images. So you can try to apply that logic in the QGIS or software you are having. So this is the Amritsar part which is showing the some of the harvesting patterns. So you can see the red ones are perfectly showing the where a crop is harvested. Green one are the standing crop. And out of that, the threshold which we have used for Mirbi, all the black pixel it's trying to capture. So this we have taken from literature. We have read some papers. Okay, this threshold value is, so you can see the all the black boundaries. Yeah, of course, we have to establish it with the ground truthing. We have to do some kind of validation check also. Okay, these areas actually are burnt or not. So these are the, so this link also will share. So you can see in a single, in a usefulness of Earth Engine, in a single code, you can track the harvest pattern, you can generate the NDVI, LSWI, and burnt area. All exercise you can do at one go. So this is the power of this platform. And even flood also very easily you can do. But we will provide the datasets for each of them, each of the tasks. Similarly, for classification, also a lot of algorithms, 3, 4 algorithms are available. Random forest or SVM. You can let me just show you some of the classification also. So like this is for Sentinel SAR data. So use every fortnightly we have created a fortnightly we have created a mosaic like for 1st to 13 June, depending on the pass. We have created up to October. Whole stack you can create around every fortnight one image. Then you can even use the land use land cover mask. Like as you can see here, we are using the ESA. You can access the ESA land use land cover already available in the Earth Engine, and you can mask out the urban areas and every other non-agriculture area also. So you can mask out these areas, and then uh, after that you can create a signatures. So here there is an option of creating signatures. If you don't have the GT, so manually also you can create signature here. Like you can create water, urban, paddy, and other crops. So if you have a GT, you can manually draw the polygons here. So like if you go here, so you can draw polygon like this. Or otherwise, if you have a GT already with you in the shapefile format, you can upload here and you can insert it here directly. There is an option of importing. So all the points are imported here. Then you have to create a signatures from this. So after importing everything, you have to like I've created a one training area. So I have merged all the signatures paddy dot other urban water other. All the ground truth had merged into single file. Then you have to generate the training data set. So whatever stacked means all the fortnightly images I have stacked one over the other, and I have sampled the region. I have a class field in that which is having the 1, 2, 3, 4 class name according to the class urban, and then you are using the random forest for classifying that. So you're basically generating the training data set, and finally this is this is my random forest classifier, and finally you use this for classifying all the signatures. So there are two options are there in random forest. You can either use the multi probability or you can use the uh, non-multi probability. Basically, in multi probability, it will assign a probability to each class. How much probability of a pixel to belong to particular class? Suppose I am classifying five classes, so it will give you the five images having the each pixel probability. So you can use a threshold. Okay, above 0.5 I will take. If the probability of 50% is there for my paddy crop, so I will mask it out. So here I am using more than 50% only. So I want to make sure if the probability image is greater than 0.5, then I will use. So this set of all the things you can, and after that also you can post processing lot of things you can apply. You can for checking like in the October I will check September image NDVI, because if paddy is there, definitely NDVI value should be more than 0.5. So those post processing also you can apply here. So I filter out those pixels also. Those will be very nominal, but you can filter out those pixels also which are non-agriculture or very waterlogged areas. You can apply the filter. Okay, throughout the season the backscatter value is less than -20. Definitely it's a waterlogged area. So these checks also you can apply in the same model, and finally then you can get the, and here you can do the basically all the validation also. If you have a, you can distribute your points, training and validation. So these kind like this, if I run this, so so I have what I have all the things I have used the stacks SAR images. Then NDVI image also I have used for filtering out the non-agriculture kind of areas where always the NDVI values less than also. Then impure class pixels also layer I have generated. Okay, these are the impure class. The urban, it is falling on the urban areas or some waterlogged areas. And finally, it will then give me the classified image. So I think it will take some time because it is running for whole Punjab states. So it will take some 2, 3 minutes. So all the tasks at one go you can do. So, but limitation is there. If you try to run this for very big area, it will fail. It will show the error here for compute, because for the free account, the computation is limited, computation resource. But the Punjab is a small state, so you can run. But in the big, in the case of the big states, it's difficult. But these same things, ML models and everything can be applied in the other like Python. Lot of Python-based libraries are available. If you have a ground truth data, you can export the images. Either through API, you can access the images and you can generate the, uh, you can run those models. Okay, so all this data sets and these links we'll share, and we'll upload the data sets also. By task 1, task 2, we'll create the folder like this. So सबके email पे या will number WhatsApp. OneDrive will upload ना on OneDrive. Okay. So we'll Tomorrow we'll as you can see now it has classified, but still you can see some of the area is underclassified as signatures are very limited, only 12, 8, 5. So basically you need to, also we have used some threshold for probability. So your signature still need to be improved. As you can see, some of the areas here is underestimated. So we'll share this link and data sets and we'll expect you to do the analysis on your own and try to generate the logic and output. So thank you.